Hi students, welcome back. We'll be doing chapter 5 soon. And what is chapter 5? Chapter 5 is solving exponential equation. So what is an exponential equation? Let's look at one example. Aha! Are you able to solve this? Right, as promised in the first slide, let's look at these questions we are going to solve. Yes, what are the values of x that can satisfy these equations? Now, before we actually plunge into giving the solutions, let's look at the thinking process. First of all, what does 27 to the power of x and 64 to the power of x, etc. remind you of? So you have to scan the database, your long-term memory or short-term memory, the database. Can you find any connections? Can you find any concepts that you can apply? Which topic did you see this 27 to the power of x and 64 to the power of x? But it comprises of the base, 64 and 27 is the base, x is the power. Which topic is that? Yes, the topic where the topic of indices. Okay, where we learn all the rules of the indices, and then what concepts can you apply? Let's look at this number 27 first. Is it possible to write it as some base? Yes, 27 you can write it as 3 to the power of 3. And how about 64? What can you write 64 as? Right, you can write 64 as 4 to the power of 3. Now, why do you want to write 27 as base 3? And why do you want to write 64 as base 4? How is it connected to 48 and 36? Right, 48, we can actually further break it down into 3 times 4 squared. And 36, how about 36? Yes, we can break it up further into 3 squared times 4. Right, so that is the reason why we expressed all this number 27 as base 3, 64 as base 4. Because this is how all these numbers are connected to one another. Right, so the next thing we're going to do is we're going to rewrite it. Because if you were to recall, we learned this rule in the chapter under indices. If you have a to the power of m bracket to the power of n, you can actually write it as a to the power of n bracket m. Right, both of them will give you the same answer, right? Both of them will give you a to the power of mn or a to the power of nm, right? Right, so from here to this step, which rule have I applied? Yes, if you were to recall this one here. Okay, we have just applied the rule that I've written on the screen. And then what do you think is the next step that we can use? So far, what are the methods that you have learned in solving problems? Using patterns, solving equations, using trial and error, guess and check, draw a diagram, or we can use substitution, right? So how can we employ substitution in solving these questions? Yes, we're going to let 3 to the power of x to be a and 4 to the power of x to be b. And let's see what happened at the next slide. Alright, let's continue our story. So this is where we have stopped at the previous slide. And we mentioned that we're going to replace 3 to the power of x with a and 4 to the power of x with b. So how would the equations look like after the substitution? Right, this is what you'll get. A cubed plus b cubed over ab squared plus a squared b equals to 193 over 144. And do you remember how we factorize a cubed plus b cubed? Do you remember the formula? Yes, a cubed plus b cubed can be factorized into bracket a plus b followed with a squared minus ab plus b squared. How about the denominator? Is there any common factors? Yes, you will see that you can actually factorize ab from the denominator to get ab bracket b plus a, and that will be equals to 193 over 144. Can you further simplify it? Yes, of course you can, because you will see that a plus b divided by this a plus b at the denominator will give you 1, leaving only a squared minus ab plus b squared over ab equals to 193 over 144. So how do you go about solving these equations? Yes, you can multiply both sides of the equations with 144ab. And this is what you'll get at the next solutions, at the next step. And then if you put everything on the left hand side, what you get is a quadratic equations where you can just use a calculator to help you factorize it, where you can get 9a minus 16b multiplied by 16a minus 9b equals to 0. And then we can apply the AB product rules to get 9a equals to 16b, right? And why is it that I want to find a over b? Because remember that earlier on, I actually substituted a as 3 to the power of x and b as 4 to the power of x. So that's the reason why I want to make a over b on the left hand side. Right. And you see that I need to do some algebraic manipulations to your 16 over 9, because clearly 16 is not connected to 3 in any way, right? However, you can actually write 9 as 3 squared. So what is it? What should I do to 16 over 9 such that I can just compare the numerator and also compare the denominator? Right, so do you recall this rule? Or rather, I need you to recall this rule. If you have this rule, it's actually equals to b over a bracket to the power n, right? So in other words, I can actually write 16 over a as 9 over 16 but to the power of negative 1. And from there, we can actually write 9 as 3 to the power of negative 2 and 16 as 4 to the power of negative 2. And from there, one solution for x will be x equals to negative 2. How about the second factors? Yes, second factors will be 16a equals to 9b. And then if I would find a divided by b, that will give me 9 over 16. And here this is easier because, why is it easier? Let's look at it. Correct, I can just simply express 9 as 3 squared and 16 as 4 squared. And from there, the second solution will be x equals to 2. Now the next step is, you need to ask yourself is that, how can I be sure that my answers are correct? Yes, so you will have to substitute x equals to 2 into the original exponential equation and see if you can get 193 over 144 on the right hand side. Likewise, for x equals to negative 2, do a substitution into the original equation and see if you can get 193 over 144 on the right hand side. Right, so are all solving exponential equation this difficult? No. So we're going to start off with some easy ones and progress to the more difficult ones. So I'll see you in the next video.